Welcome to I'd Print That. I'm Joe, and this last week, spent a lot of time with my cat. She's doing a lot better. Got her on some steroids and really seems to have picked her up, so she's definitely on the mend. Though, I mean, it is cancer, so things are positive. It was looking good. I didn't get any maintenance performed this week. I've been waiting on some parts to arrive, and those did show up today. I got a couple new fans for my Me Creator, and I also received a auto leveling sensor for my Prusa i3. Here in the next week or two, I plan on getting that auto leveling sensor installed and configured. So bed leveling on that will at least be a thing in the past. That's an exciting thing. Got to figure out how to get this installed. It really didn't come with any instructions, though there is an online wiki I will need to go through. I don't think it's going to be too difficult, but we'll see how things progress. Past that, this is the last recording of September, which means you only have a little while left to get the low poly Bulbasaur if you run it out to our Patreon page and pledge us $5. Today, I want to take some time and talk about the 3D printing industry and the 4 distinct market segments that it serves, which are at different stages of evolution. Currently, the most mature market for 3D printing is the production of prototypes. 3D printing rapid prototypes has been around since the late 1980s, and it is used to create prototypes and concept models. This can significantly speed up and otherwise assist in the design and pre-production process, and as a result save companies a great deal of money and help improve the function of final products. Material extrusion 3D printers cost anywhere from a few thousand to as low as a few $100s, allowing designers to make design prototypes for many situations. By using a more expensive 3D printer that uses material jetting or powder bed fusion, a designer can produce highly detailed, functional prototypes out of a wide range of materials with the option of producing prototypes in full color. Next, and growing very rapidly, there is a use of 3D printers to fabricate the molds and other tooling from which final products are made. Currently, the fastest growing area of 3D printing applications is the manufacturing of production tools. It used to be that the molds, patterns, jigs, fixtures, and other tooling required to make final products had to be handcrafted, which was quite expensive. Molds used to create plastic parts often cost companies tens of thousands of dollars. It is now possible to use 3D printers to produce low-run injection molding masters for hundreds of items, and final high-run mold masters for a few $1,000s. The impact 3D printing has had on the traditional production process has been quite dramatic. By using binder jetting, a 3D printing process that uses a printhead to selectively spray a binder or glue onto successive layers of powder, it also now is possible to directly 3D print sandcast cores and molds. Traditional sandcasting required patterns to be crafted out of wood or machined from metal, then casting sand would be packed around it. The pattern would need to be carefully removed from the mold or core, however, and this process was not always easy or successful. Once a pattern was removed, a molten material, often metal, would be poured in to cast the final product. By using 3D printers to manufacture sandcast molds and cores, companies can spare themselves the cost of crafting wooden or machining pattern masters. They can also cast more intricate parts from sand molds that would be impossible to fashion by traditional means. This means that, once again, time and cost savings can be very significant. One case study showed that 3D printing sandcast molds and cores can cut weeks from production times, as well as delivering cost savings of over 80%. 3D printed substitutes are also increasingly being used in traditional metal casting processes for lost wax patterns. Here, 3D printers based on material extrusion or vat photopolymerization produce wax-like objects that are later surrounded by a traditional casting material such as plaster of Paris. The mold is then heated, causing the wax substitute to melt and drain away. Then molten material, like metal, is poured into the mold. The use of 3D printed lost wax substitute patterns is especially popular in jewelry or other industries that make small, low-run, intricate metal parts. It is becoming more popular now that it is possible to purchase high-resolution VAT photopolymerization 3D printers for only a few $100s. After that comes the direct digital manufacturing, or DDM. This is the use of 3D printers to make final products or parts. According to the American Society of Manufacturing Engineers, DDM refers to the process of going directly from an electronic digital representation of a part to the final product via additive manufacturing. Some final products may be molds or other items of tooling as mentioned before. However, in industrial sectors including space, aerospace, automotive manufacture, healthcare, toy making, arts and crafts, designer goods, fashion, and computers, we are starting to witness the application of 3D printing to directly fabricate parts, modifications, or final products. The drivers of the DDM revolution are countless and include the ability to use 3D printing to optimize the geometry of final parts, often saving raw materials in the process. This allows parts to be produced with geometries that could not be created via traditional means. It also allows for the manufacture of low-run, highly customizable products that would not be cost-effective to manufacture without 3D printing. 3D printing can also help to improve sustainability via increased localization. Right now, many of the companies dominating DDM are in the space and aerospace sector. SpaceX recently flew one of its Falcon 9 rockets with a 3D printed main oxidizer valve and is using powder bed fusion to 3D print the engine chambers for its manned space capsule. Additionally, Airbus is now incorporating 3D printing components into its aircraft, with its latest A350 XWB containing over 1,000 3D printed components, and GE Aviation's new CFM LEAP jet engine incorporates several 3D printed parts, including one component that would be impossible to make using conventional manufacturing methods. In the automotive sector, 3D printing is now widely employed to make parts for F1 racing cars. A company called Local Motors is intending to launch a vehicle called the LD3M Swim that will be around 75% 3D printed by volume. And Swedish automaker Koenigsegg's Agera 1-to-1 features 3D printed variable turbo housings and a 3D printed titanium exhaust end piece. While the space, aerospace, and automotive sector's key advantages of 3D printing is to optimize component geometries, save expensive materials, and reduce the cost of low-run production, the healthcare sector has a more important benefit: customization. In the U.S., 3D printing has enabled digital dentistry, with dental applications starting to be routinely 3D printed based on patient scans. Hearing aid shell manufacture is also being transformed by 3D printing. 3D printing is additionally starting to be used in the manufacture of custom prosthetics as well as in surgical planning. Other notable pioneers of DDM include producers of jewelry, designer goods, and toys. Finally, we have the very new market for personal fabrication. The market for personal 3D printing has grown very rapidly, with over 1 million personal 3D printers expected to be sold annually by the end of the decade. Currently, the kinds of objects that can be fabricated on personal hardware are limited at this time, though. Despite fulfilling the dreams of some enthusiasts, personal 3D printers are in a product category that is in a very early stage of development. For people who are content to produce objects out of thermoplastics or thermoplastic composites, there are many 3D object repositories that provide access to free or for a fee 3D models to download and print. It is already possible to visit a website such as Thingiverse or My Mini Factory to download a replacement part for your car's dashboard, a new lens cap for your cameras, or even a whole game. They can then be printed out at a serviceable quality on a desktop 3D printer costing less than $1,000. 3D printing is just starting to facilitate a new age of personal fabrication in which anybody can get their digital designs turned into material reality and even offered for commercial sale. This revolution is being aided by a host of services that allow anybody to supply a digital file that can then be 3D printed. Companies such as Shapeways and iMaterialize allow people who have uploaded 3D models to open an online store from which their goods can be sold. This allows anybody to get into the manufacturing business without any investment in stock or production tooling. The 3D printing company takes the customer's orders, produces the product, ships it, and then provides a revenue share to the designer. Don't have a 3D printer but want something printed? Or do you want some education or some hands-on experience with a 3D printer? You can check out 3D Hubs or look for a local makerspace. Makerspaces are a great place to ask questions, get hands-on experience, and see what 3D printing really is all about in a one-on-one setting. I know many places have local makerspaces, and I had a friend of mine who lives in Oregon who wanted to have something laser cut. Now, I don't have a laser cutter myself, and he was looking to have something, send me a file to get it laser cut and then sent back to him. And I told him to go look for a makerspace in his area so he could get that done a lot sooner and probably a lot cheaper than what I would be able to get that done for. And he was able to do that. He found a makerspace in his area, and while I don't know if he went and had the product manufactured, it's still nice to know that he was able to find the service that he was looking for and probably was able to get it done at a fraction of the cost of having it sent off to some big company. Not a whole lot of news this week, though I did find a couple of really neat articles I'll link to. One I definitely wanted to take some time and talk about, or at least share with you guys, is that 3D printing company MakerBot has announced that they have 2 new printers and they have an official focus shift away from the general DIY printing and home users towards the specialized worlds of professional design and education. The MakerBot Replicator Plus and the Replicator Mini Plus are the new generations of existing products, both promising a similar process and better results. Launched on September 20th, they were accompanied by a new software system and some supplementary services, as well as a new printing material. The Replicator Plus looks similar to its predecessors, but MakerBot promises that nearly every part of it has been rebuilt. That includes an extruder motor system that allows for faster and more precise prints, a build plate that will grip better and bend to make removing the finished product easier, and a significant reduction in noise. MakerBot says it wants its printers on desks and not in back rooms. It can print objects up to 11.6 by 7.6 by 6.3 inches, which is notably larger than the 5th generation Replicator's 9.9 by 7.8 by 5.9 inch objects. The price for the new printer is $2,499, but it will be discounted to $1,999 through October 31st, which is cheaper than either the 5th generation Replicator and the experimental Replicator 2X. MakerBot is building for designers who prototype new products with 3D printing, one of the most popular uses of relatively cheap 3D printers. The Replicator Mini Plus, meanwhile, is an education-focused evolution of the Replicator Mini that launched in 2015. It has a slightly larger build space than the Mini, capable of producing objects that are 4 by 5 by 5 inches. It is supposed to be 58% quieter and includes many of the same technical improvements as a Replicator Plus. It will sell for $1,299 and is currently discounted to $999. MakerBot has already made significant overtures to educators and currently says that 5,000 schools across the U.S. are using its 3D printers. The Replicator Plus will also support using a new material that MakerBot refers to as Tough PLA, a plastic filament that it says will be more flexible than its normal PLA material while still printing reliably. Though Tough PLA isn't meant for making colorful 3D sculptures, it comes in slate gray and isn't supported by the Mini Plus, but it will theoretically make testing industrial prototypes easier. Both the Replicator Plus and the Mini Plus will use MakerBot print MakerBot Mobile, and 2 new software tools that are supposed to make 3D printing less daunting and more foolproof. Among other things, MakerBot supports a number of CAD file formats, instead of requiring designers to export objects to the standard 3D printer STL format. It also helps automatically position objects for maximum efficient printing. One of MakerBot's goals is creating an ecosystem around its printers. For professionals, there's a portal with instructions for things like sanding already printed models, or making molds out of them for finished products. For educators, there's a new section on Thingiverse where teachers can upload printable objects with lesson plans, letting them share ideas for classroom activities. Overall, MakerBot wants to eliminate the anxiety over setting up its devices and fixing botched print jobs. MakerBot CEO said that the printer's initial low pricing is a very long-term play for the future of 3D printing. Originally associated with the DIY maker culture, MakerBot has struggled to find a new identity since being acquired by 3D printing giant Stratasys in 2013 and moving away from an open-source product, which caused some industry backlash. Since that time, MakerBot has gone through several rounds of layoffs, shutting down its manufacturing center in Brooklyn and outsourcing production to China. This to me seems like an interesting move for MakerBot, since its focus in the early days of 3D printing was geared towards the DIY and home markets. It seems like Stratasys has wanted to fill that gap that is right between the industrial sector where Stratasys sells their machines and where the new breed of low-cost printers are. There's that mid-range group of consumers that they're really kind of going after. I think it's an interesting step, and there's a good chance that they'll be pretty successful with that. Will they continue, or will they move back into the low-cost DIY enthusiast sector? It's a tough call. There's many other printers out there with the new 3D printers, especially with price. It's going to be a hard market to get into. There's so many inexpensive printers out there now that it's hard to justify spending $1,200 to $2,000 on a printer when you can get some pretty decent ones at the $500 mark or sub $1,000 range. I know when I was first looking at getting into 3D printing, I thought that if I spent the $2,500 and got myself an Ultimaker, that I would have the best machine on hand and it would do all this stuff that these cheap machines or less expensive machines could do. And honestly, that's not the case. There's a lot of inexpensive machines out there that will do just as good a job. You're definitely paying for a name. Ultimaker has been around a while, but that doesn't always make it the best choice. A lot of the large manufacturers aren't really willing to take the risks that the small guys are. They know that if they take a risk and they can pull it off, that they can stand out from the crowd. Whereas the Ultimakers and the MakerBots and those other large printing companies know that it's risky to take these chances, and they're probably more apt to sit back, see what happens with the industry, and then move forward. Take cell phones, especially over the last 5 to 8 years. When the iPhone first came out, it was new, it was different, it was revolutionary, it was the best thing available. Android phones existed at that time, but they weren't as polished as the iPhone was. As time has gone on, and I'm probably going to get flamed by this, Android has definitely evolved more than the iPhone has. The phone's features and apps and overall quality of products has improved greatly, where it feels like Apple is now lagging behind, whereas Apple at one point was the industry leader, which is a great comparison because you can look at your iPhone as like an Ultimaker or a MakerBot. You're going to spend a lot of money on it, you're going to get a reliable product, but it's not necessarily going to have all the features as another 3D printer out there. If you're looking at getting into 3D printing or picking up another 3D printer, you don't always have to go for the big dollar printers. My Me Creator 2, while it doesn't have a very large build platform, it costs under $500 and has been a very reliable machine. Anytime you go to pick up or anytime you're looking at purchasing a 3D printer, make sure you check out what other people are saying. Just because that machine has a very high price tag doesn't mean it's the best machine out there. On the flip side of that coin, just because the machine is inexpensive doesn't necessarily mean it's the right machine for you. You've got to find the printer that meets your needs. Don't try and get a printer and then make it do what you want it to do. Make sure you get the right printer. If you want to do just regular trinkets and knickknacks and quality doesn't necessarily fit in there, you can get yourself a very inexpensive FDM printer. If you want to do high-resolution prototypes, then you may want to look into like a Formlabs SLA printer or something similar. Time and research are definitely your friends in that aspect. I want to thank everybody for listening. It has truly been educational for me. I've had a whole lot of fun doing this and look forward to doing it a lot more. I love hearing from everybody who's listened. I keep looking at the statistics in SoundCloud. It really does blow my mind that I'm getting as many listens as I am, and from all over the place. We got our intro music from Victor Berggren in Sweden. It's amazing. I'd never dreamed that somebody in another country, much less across an ocean, would listen to what I have to say on 3D printing. It's definitely mind-blowing. I am looking at doing some things. I made comment last week. I have a project I'm working on, but I've also been looking at attending CES this coming year. That's in January. Getting all of that stuff set up. That's in Las Vegas. There is an entry fee into that, and I'm working on getting that all put together. And I think that'll be kind of a cool little thing where I can actually give my take on the things at CES rather than reading what somebody else's experiences were and then giving you my opinion on their experiences or what they had to say. So it's really exciting. Looking at doing other things. If you think you can help out, send me a message. Let me know. I've got a few roles that I would like to try and fill. I have a position for taking care of the social media and kind of be the people side of the podcast. I'm not a social media wizard by any stretch of the imagination, and I think having a person who knows more about that would definitely be beneficial. If you know somebody, or if you are that person, feel free to send me some info and we'll talk more. If you want to help other ways, we've got our Patreon account where you can provide $1 and $5 per month pledges. At $5 a month, we'll send you a print of the month. It all goes to help support the podcast, what I do. This would help me get to CES. This would help pay any of the bills that we've got for the podcast. There's little bills that we have. It's not much. Web hosting, P.O. Box, little things like that. If you don't want to pledge that way, you can always go and buy things from our website at I'dPrintThat.com. Click on the supplies link and purchase your filament or other 3D printing supplies from us. That would be amazing. It gives the podcast a small kickback. You get the same products and quality and everything else that you expect from Amazon. Give us a like, follow, subscribe via SoundCloud, Twitter, Instagram, Facebook, YouTube, and show your love. That pretty much covers it for this week. I am Joe, and remember, if you can imagine it, you can print it.